We're talking about motion graphs in this video, and I'll start with a distance time graph. Of course, you know that a graph is a pictorial representation of information, a two-dimensional representation of two different variables. In this case, we're looking at two different variables, which are distance and time, displacement and time, speed and time, velocity and time, and probably acceleration and time. So we start with distance time graph. Here we represent the y-axis, the vertical axis with distance, and the horizontal axis is represented with time. So we want to see how the distance varies with time. The picture here shows how the distance varies with time. Here the distance is not changing. The person is just at one spot. After walking a distance of say 5 meters, the person decided to come to rest. So from that time, let's say even up to 5 meters or 5 seconds later, the person position has not changed. So since position has not changed, so the person is at rest. If I draw this same or represent this same information on a displacement time graph, just as you have here, it's going to give me zero velocity. It means the body is still at rest, it has no speed. Now let's represent uniform speed. How about the case when the body is moving at a uniform speed? That is, the speed of the body does not change with time. We say the speed is uniform. On a distance time graph, or let's say it is given by this table of distance covered with time. The body starts from rest because time t equals 0. The distance covered is 0. After 1 second, cover the distance for 5 meters. After 2 seconds, distance for 10 meters, and so on. So you can see that for equal time interval, the increase in distance is the same. That is, the body covers equal distances at equal time interval. This is how to define uniform speed. In the last video, I didn't define it. If you're asked to explain this by uniform speed, you say this is a case when the body covers equal distances at equal time interval, irrespective of the time interval. So here, 1 second later, the interval is 1 second, and distance covered for every 1 second interval is 5 meters. So you can see that this body is moving with a uniform speed. And if I plot the graph of this table, that is the distance time graph of this table, I have the plot here: 1 meter, 1 second I have 5 meters, 2 seconds I have 10 meters, 3 seconds I have that. And I draw the graph or a line joining the different points, the different plots. It's going to give me a straight line graph that actually starts from 0. So when you have a linear graph of a distance time, variations of distance with time, we can here see that the slope of this graph or gradient is speed. The slope of the graph represents speed, and the slope of the graph is defined as the change in the vertical parameter or vertical variable, which is the distance, change in distance over change in time. This is how we define the slope. And how do I find my change in distance and change in time? I can look out for any 2 points, exactly on the graph line, not outside the graph. So if I choose this point, I call it point 2. I choose this lower point, I call it point 1. The next thing to do is to draw a slope triangle. The slope triangle is the right angle triangle. The horizontal along the time axis, and I draw the vertical line or the opposite side along parallel to the distance axis. So that this point here, from this point to this point, let me call this point, this is my point 1, let's call this point 3, is my change in distance d. And between point 1 and point 3 is my change in time t. So that if I want to find my change in d, point 2, I'm supposed to write this as d2 minus d1 over t2 minus t1. What's my d1 or what's my d2? I trace this to the distance axis. This gives me 20 here. That's 20 there. I'll write there 20. Minus come to point 1 to evaluate to pick out my d1. That is 5. Over what's my t2? Come to the same point 2. Take it down to the time axis. That gives me 4 seconds. Minus what's my t1? Come back to point 1. Take it down to time axis. That gives me 1. So that the slope of this graph is 15. That's this minus this over 3. That gives me 5. And since the slope represents speed. Why? Because speed is defined as distance over time. The slope is d over t. Don't allow this thing to confuse you. Just ignore this delta. Take it as d over t. So since speed is distance over time and the slope is defined as d over t, which is distance over time, it means that the slope of this graph represents speed, meter per second. Now that shows the slope of a straight line graph is always constant. The slope of a straight line graph that is inclined at some angles to the horizontal is constant. That means whatever the slope is, the same thing applies to the speed. If the slope is constant, it means the speed that is derived from the slope will be constant. If the slope is non-constant, non-uniform, or in a case where the slope is changing, it means the speed which is derived from the slope will be changing. So therefore means that here that the speed of the body will equally be constant. So that constant or uniform. So which means you can say that this straight line graph with an inclination to the time axis represent constant speed. This is the graph of constant speed, a distance time graph that represents constant speed. That does not mean the speed is increasing. The speed is constant, just that the distance is increasing at a specific rate. The rate of increase of distance is 5. The 5 meters per second means that the distance covered by the body increases by 5 every second. Okay, after 1 second, the distance covered was 5. After the next second, the distance has increased from 5 to 10. So the rate of increase of distance, that is speed of the body, which is 5 meters per second. Now, if I was to draw the same graph, let's say this was displacement against time. On a displacement time graph, I'm going to have a straight line graph also, which represents constant velocity. So this is a graph of constant or uniform velocity drawn on a displacement time graph. Of course, displacement velocity is defined as displacement over time, whereas speed is defined as distance over time. Okay, so that is the slope of uniform speed or the graph of uniform speed or uniform velocity. Now, let's look at the graph of still distance time graph. And I suppose the graph is not a straight line. The graph is like this. You can have a distance time graph that looks like this, or even a displacement time graph, distance, or displacement time graph. This S means displacement, M means the unit. This one is the unit meter. Then this time, the unit is second. We can have a distance or displacement time graph that is a curve. Here, it means that the speed of the body is not constant. The velocity is not constant. This is a graph of variable velocity or speed or velocity. And if the velocity increases at a steady rate, it means this is a graph of uniform acceleration. We can call this the graph of uniform acceleration. Okay, so we can also evaluate or interpolate uniform acceleration from a displacement time graph. It's a graph of variable speed, variable velocity, or uniform acceleration. That is, if the speed or velocity increases at a steady rate, then it's a graph of uniform acceleration. I can also show you that for a uniform deceleration, still from a distance or displacement time graph. So this is distance or displacement time graph in meters. Then I have this time. So for that one, it will look like this. So when the graph curves continuously downwards, you can see this is a graph of variable speed or velocity, where the velocity reduces at a constant rate, variable speed or velocity. So this is a case where the velocity or speed reduces at a constant rate. So which means this is the same thing as the graph of deceleration. The body is decelerating, you know, at a constant rate. And if the speed reduces at a constant rate, it means that it's a graph of constant deceleration. It curves continuously downwards, as you can see in these graphs of motion. So we have seen the graphs of distance and displacement time graph. The next video we shall look at speed and velocity time graph.